2 curves. All right, so this is the disk method for finding the volume. So we're going to take all those regions we've had for areas. As a matter of fact, on the AP exam, what they'll do is they'll say, find the area between these 2 curves. Now take the area between those 2 curves, revolve it around the x-axis, or around a line parallel to the x-axis, which creates a hole or a washer, or revolve it around the y and then calculate with integrals the volume. Or they might just say, guys, they might just tell you just to set it up and then leave it, because sometimes it's more complicated than you'd have time to do. Or they might have that in the non-calculated portion. So here's the premise behind this. Look at the function. This is just a simple y equals x squared. Consider the region bounded by the function, the x-axis, and x equals 3. So we have this region right here. You can just watch this. You don't need to write anything down yet. So we have this region right here bounded by those 3 things. There's the region. When you take and revolve the region around an axis like the x-axis, you take that region right there, you do a little arrow to show what we're revolving around. You end up with something that looks sort of like this. Okay, so if you take that and picture what it looks like when you revolve it around the x-axis and then fill in all the blanks, you end up with a 3-dimensional sort of shape. It's kind of like so let's just look at one rectangle, and this is what's at the heart of it. When we say disk, what we're really talking about is a hockey puck looking sort of disk. So it's like a hockey puck up on its end. I'll show you what I mean. But let's look at one rectangle in our region rotating around the x-axis. The rectangle in this method will always be drawn perpendicular to the line we rotate. So consider one single rectangle. So you guys see that rectangle? Yes. You're going to end up drawing this tomorrow, so you don't need to write this down now. You'll end up doing Thursday? Thursday, yes.
Here's one of those.
You literally said it was a literal mess. We can just decide. When I say tomorrow, I mean the next time. So take this right here.
Get out.
Okay.
Hey,
I can do
show kindness and friendliness
That's
in the
right.
top of the circle, please.
That's right. We're all in this together. Here we are.
Yeah,
So
I'm in respect to Y right now.
all right. So we're going to take this little rectangle. This is just one of the rectangles, and picture it as just like this. We always do in calculus. It's like that rectangle is taken as small as you can get it, or as narrow as you can get it. And you're going to take an infinite number of them and add them all up. That's kind of the calculus idea. But you take and revolve this around the x-axis, you get something that looks like a circular disc. It's really a cylinder from geometry, but it looks kind of like a hockey puck. You can picture a hockey puck sitting up on end. So there it is. That's a picture of taking that rectangle and revolving around the x-axis. So when we say cylinder, this is the cylinder we're talking about. Do you guys remember the volume formula for a cylinder? What's the area of a circle? Okay, and how many circles do you have stacked up? Height circles stacked up. So it's pi r squared h.
It's just taking a Riemann sum.
What's that?
It's just taking a Riemann sum.
It is. So check this out, guys. What's happening is the radius. This is where we get into calculus. Okay, we've moved from the realm of geometry to calculus. The radius is an ever-changing radius here, right? Corresponding to what? The function. So instead of pi r squared h, we have pi f of x squared h, and you integrate that thing from 0 to whatever, a to b. That's it. That's the volume. So it's okay, this is really important. Listen, I'm going to write it down, but and this is the calculus portion because it's ever changing, right? But the radius is just the function. That's it. And we're going to talk a little bit about the washer method, and that's just when as you go from left to right, if you develop a hole through the middle, you've got to subtract the two functions to account for that hole in the middle. But this disk method, there's no hole in the middle here, this is a solid shape that we're creating by revolving y equals x squared about the line y equals 0 to the x-axis. So what is the formula for the volume of a cylinder? You might want to write this down. So write this down. Some of you didn't know it, but pi r squared h. So volume equals pi r squared h. That's for one cylinder, one infinitely small cylinder, corresponding to one particular value of f of x. So its volume formula for a cylinder is V equals pi r squared h. And all we're going to do is bring the function into the mix for r and integrate that thing to bring the Riemann sum idea in, that we're adding up a whole bunch of these polypucks. That's about it. So it's not a huge stretch or jump for us for what we've been doing. So here's our animation of what's happening here. This is a different function. It's not y equals x squared. But so you're taking each of those pi r squared h's and you're adding them all up. And that's where the integration, or the integral, comes in. It's our accumulation function comes in. So here's the disk method. If you have volume, and you need to write this down. Volume equals integral of pi r squared h. Volume equals integral of pi r squared h, and we got to swap out for r f of x, and h becomes dx. Why is that?
Because it's the increment for the height of each individual disk.
Yep. It's the increment, and that's what they're doing right here. You might need to draw this picture, but it's the increment for the height of each individual disk. That's exactly what it is. dx is the h, and f of x is the r. And we integrate from a to b as you go from left to right. And you can apply this, just like we did in today's lesson, to revolving around the y-axis. You can change the limits of integration to correspond to y. You can write your functions in terms of y. This is the disk method. I call this the no gap method. So when you revolve the region around a particular axis and end up with no gap, it's a totally filled in one, and then you can use this method. If you end up with a gap, there's a different method used. And then it's just a matter of, it's really analogous to what you did today. There's different ways to do the same problem. You might have to break it up, you might have to think different ways, but you can, well, in every problem for calculus AB, you can do it either with the disk or the washer method, one or the other. You just sometimes have to get a little creative. Yeah.
Will we also be doing this for the y-axis?
Yes, we will. So, and I'll do some examples with you as well. But this is the formula. It's volume equals integral from a to b of pi f of x squared dx. So make sure that's written down. Yeah, we may even get to an example today over the y. The example that we're going to do with the banana tomorrow, the banana is going to be, it's going to have one end on the origin, and the other end about 12 centimeters out. And then it'll be a curve, so it'll be a square root sort of function. And so it'll be an example of this formula exactly. So it'll be with respect to x. Of course, we're gonna take that curve, revolve it, and then fill in all the middle. So it'll be a no gap solid that'll sort of model banana. It's pretty close. All right. So let's see. Find the volume of a solid. Go ahead and write down this example. We'll just have this one example here, and then we'll pair this with the banana example. So find the volume of a solid of revolution generated by revolving about the x-axis. The region in the first quadrant bounded by the x and y-axis and this ellipse. And I will show you what the picture of that looks like. But write down the problem. So you have one example going into this. You guys remember how to graph an ellipse?
Oh, you kind of. So
Do you remember do you remember what the general form of it is?
it's like if X squared over a.
Yeah, good. Yeah, x squared over something squared plus y squared over something squared equals, yeah,
So you
1.
just divide out by 36.
You would divide out by 36, and this is a carefully chosen problem. It kind of divides nicely.
Yeah.
So you can welcome to do that next. I'm going to show you what it equals on the next page, so you don't have to do all the algebra there. And I'll give you a picture of it. On your calculator, if you wanted a picture of this, like if you didn't remember how to graph it, you'd have to solve for y, have two different functions, the plus or minus version, and then only look at it in the first quadrant, which can be done. We're not going to take time to do that. So we're in the first quadrant, bounded by the x and y axes, and then this ellipse. Where's this ellipse centered? Yeah. So here's sort of what it looks like. This is what the top half of it, I guess, would look like. It's a little distorted. That's because of the axes. But the top half would look like this. It's what you see in red here, and we're only revolving the part of the ellipse in the first quadrant. This is supposed to model a cucumber, as a matter of fact. Does it look like a cucumber? If I were to continue all the way through, or half of a cucumber, this is half a cucumber. We could double it.
Yeah. You're welcome.
Okay, so the way it would work is this. Here we have, this might take a little bit of connecting to the algebra. We had, from the previous page, just real quickly, 4x squared plus 9y squared equals 36. So 4x squared plus 9y squared equals 36. We're solving that for y to get this. So they're just subtracting the 4x squared over and then dividing through by 9 to get that. So this is our f of x that we're plugging into our function. So f of x, remember, is r. dx is our h. Pi is just part of the formula. And then we're integrating it from 0 to 3 in this particular problem. That's it. I mean, the setup is just like you've been doing for area, but we have the pi r squared in there.
Why don't you root the whole thing?
I'll show you. So this, when we solve it, is going to have a square root symbol over it. So this thing's already been squared. So let me finish this. Let's do this. So we have 9y squared equals 36 minus 4x squared. Divide through by 9. So y squared equals 4 minus 4/9 x squared.
Oh, and then
this,
squaring it
yeah.
so it cancels.
Yeah. So what they did is they took the y equals just the positive square root of 4 minus 4/9 x squared. And then when you square that, so really up here, that's what's getting plugged in. That's what ought to be up here. Let's put that in. That might make more sense. If you do the algebra, you have this squared. So there it is. I would write it like that. And then that squared is just to cancel out. So you end up with the integral of from 0 to 3 of pi 4 minus 4/9 x squared dx. That's it. The f of x. You just have to understand that the f of x is the function. The radius is changing continuously. Unless it's a horizontal line.
So for this, because you want to do it on both sides of the y-axis, you just take whatever you get and then time calculate. I'm assuming.
No. Well, if I wanted to find this other half over here, I would double it.
Yeah.
But in the original problem, it said find the volume of the shape formed in the first quadrant.
Just that's perfect.
But I was just telling you where this came from. They had like a
cucumber instead of a banana that they used as their real life model, and they found this function, the ellipse, modeled the cucumber. That's where it came from. Who came up with that? Cucumber shakes.
Should we switch?
No, I think so.
I already have the banana. I already bought a bunch of bananas, and they're all frozen because it works better if they're frozen. So they're all frozen. I use Surf Safe. None of my kids have. I wash mine. I froze.
To bananas.
So I'm not gonna get
Don't come thirsty. Leave in the last half hour. I got it. Here, does anybody else?
Candidates.
So, and this one is one that can be done all by hand. So you get that puppy down. So you have one example going into tomorrow or Thursday. Sorry.